Okay, welcome everyone to this CDS Lab RCN webinar. My name is Cecilia Dom at the PI for this project, and we have today Dr. Peter Adriaens. So Nusha will be introducing the speaker. Nusha, I'll pass it to you.
Sure. Thank you, Cecilia. Good morning, everyone. Actually, good afternoon if you're in the East Coast. It's truly my pleasure to introduce my friend and colleague, Dr. Peter Adriaens, to talk today about how data will drive financial innovation through food, energy, water nexus. Peter is a professor at the University of Michigan, and he has an appointment with the Civil and Environmental Engineering and the Business School, as well as the School of Environmental and Sustainability. He directs the Center on Smart Infrastructure Finance and focuses on efficient infrastructure finance, financing mechanisms for public and private infrastructure systems, such as water, energy, waste, transportation, mobility, and also a big focus on data-driven financing, which is, I'm hoping that he would be covering part of that today, and trying to understand how we can use the digital transformation we are experiencing as part of the financial model. The center that Peter is directing is a co-founder of the university's FinTech collaboratory with the FinTech initiative in the Ross School of Business and the Center on Finance, Law, and Policy in the Ford School for Public Policy at the University of Michigan. He also recently published a book on financial innovation for industrial renewable, Alta Press, Finland. Dr. Adriaens have received his PhD from UC Riverside, and he has his master's and bachelor's in biotechnology and bioengineering from University of Ghent in Belgium. Peter, it's such a pleasure to have you here. Thank you for joining us today.
All right, thanks, Nusha, and thanks, Nuri. Really appreciate having the opportunity to talk a bit to you on finance. Now, I want to, as Nusha said, definitely want to set the record straight. I am not formally trained as a finance person. Right, as you heard from Nusha, she said I have a master's and undergraduate degree in bioengineering, and that is correct. So in 2006, I ended up switching over full-time to the business school. I'm in civil and environmental engineering. I switched over to the business school and started working with pension funds and private equity groups and all sorts of types of investors to look at how one invests not just in individual technologies, but in infrastructure systems. So that gave me an opportunity. That's a bit of the backstory, because I had to think about how I was going to talk about finance and the food, energy, water nexus, since I really don't work directly in the food, energy, water nexus, but we have applied different financing models, including data-driven financing models in different types of infrastructures. And I'm going to try to make that transition into the food, energy, water nexus. So, but I was at the business school for about a decade or so, and mainly I wasn't really very academic, even though I was at the university, doing a lot of work more on the outside. So as I said, working with investors. I had an opportunity to go to Finland. And Finland, as many of you know about the Nordics in general in Europe, they tend to sort of be first movers in sort of this whole sustainability space, right? And in the low carbon space, and they were the first among the signatories of the Paris Accords and all that kind of all that jazz. So they invited me as a Finnish distinguished professor, which is a sort of a 3-year appointment, to actually come and work over there. And the mission was to design an investable financial model to transition Finland to a low carbon economy. No pressure. So really what they were looking at is not to pick winners and losers, as in we're going to use this technology or that technology or wind or solar or water recycling systems or desal or out of the Baltic or something else. That was not the question. The question is systemically, how can one leverage existing assets? Because we have a lot of existing infrastructure assets, as well as companies and other types of entities. How can we transition them towards a more sort of low carbon industry structure? So it was a fascinating project that I don't know that anybody had ever undertaken something like that. They essentially gave me a spreadsheet on the entire economy of Finland. So I think about an Excel spreadsheet, and it has all the financial data of all the companies, from the large corporations to the smallest startups, as well as all the government data of all the different local governments in this space. So, and when I was thinking about working on the food, energy, water nexus, which per definition is a very complex system, right? As Cecilia and I were just saying earlier, it's kind of hard to figure out where you start. There's different starting points that one can take in that system. And the same thing goes for sort of thinking about how does one finance towards, say, a low carbon economy. Now, they did want to focus in three areas, and those were transportation, energy, and the bioeconomy. And one could argue the bioeconomy is part of the FEW, right? So mainly driven by their forestry. They have the largest forestry together with Sweden in Europe. It's the largest growing forestry, and they've done some very fascinating things with that in the investment space and otherwise. So what we had to do in order to, and that's going to be a big part of how I will be talking today, is I will be talking from the lens, or through the lens of the investor, of somebody who comes in, whether it's through a public-private partnership, whether it's entirely private, or through any kind of financing mechanism. It could be a public financing mechanism too. But looking at from a financing mechanism, how does one think and look at infrastructure? So there were sort of these three lead markets, as already indicated. What we essentially had to do is map out, develop a financial network map of the various different industries. This is a high level overview, and we're going to dig deeper later on. So I need to organize what they actually have. And I think that's what we have to do in the FEW also, because the food, energy, water nexus applies differently in different localities, in different countries, in different political systems, and in different sort of different types of industry heavy countries and economies. So we have to sort of map out and figure out how to map out the network of all the stocks and flows in the economy in a particular system. And in our case, in these three, mobility, energy, and bioenergy. Then within that, we have to take a look at, okay, so now that we know all the nodes, I guess, all the stocks, I guess, in that system, we have to figure out what are the performance characteristics of these components, and where the inefficiencies in the system. Because essentially the way investors look at a system is they invest in the inefficiencies of the system to actually draw performance returns out of that. And so that's going to become a lot clearer afterwards. So once we had that information, so there was a lot of modeling, this is both data science type modeling as well as financial modeling. Then we had to build a financial and kind of a global financial model to figure this out. And these were the low carbon multi-asset renewal funds. So a multi-asset renewal fund is essentially something that a pension fund plus some government money, government that puts in some grants, maybe some first loss guarantees on debt or whatnot. It has bonds and private equity in it, and essentially invests in different components of that system to essentially shift where the economy goes, or how the economy starts thinking about becoming low carbon or more sustainable. And this is just a map. I mean, every investor always looks at, when you design a financial instrument, here's our MARV, right? How does that map out against all the other things that are out there, right? Is this a good investment for them to make? Because you can't just tell a pension fund investor, hey, invest in this. They're going to say, well, what's the alternative, right? And the same goes for the public sector. We got roads, we got water systems. There's many different pieces of infrastructure that need investing, so that return profile becomes, risk and return profile becomes important, right? So if we map it over here, it sort of had the risk. So this is risk here, and annual standard deviation. It almost had the risk of a bond, but it had the return of private equity, which is great, right? High return and fairly low risk is something that an investor is interested in. So this model invested in all sorts of projects, as well as companies engaged in projects, small and medium enterprise that participated in these projects, in the new mobility space, in the smart grid space, and in the green chemistry space. So, and then I left. So this is an example of a combination of how much set in climate bonds, how much was sort of public equities, how much was debt in the small private companies, and then how much was sort of an equity play, the private equity ownership in projects. So I came back from there, and I spent a lot of time thinking about what's next. I mean, once you've sort of been given a spreadsheet of an entire country and say, have at it. I mean, of course, it wasn't just me. We were a team of about 20, and being able to work with pension funds. How do I reintegrate back into a university? I was working at a think tank over there. And so I talked to our new department chair. I said, okay, we want to do something. I want to do something in finance in CEE. And we debated a lot with a lot of my colleagues, and I said, okay, how about we set up a Center for Smart Infrastructure Finance? And what drives smart infrastructure finance, as many of you know, are sort of the data-driven infrastructures, the integration of data in decision-making and performance assessment of infrastructure systems, whether water or energy or housing or roads or bridges or whatever you want to think about. And he said, you know, there's a lot of people here in this department from the civil side and the environmental side, if we still want to look at sort of these two silos, though I am vehemently opposed to that, particularly in the context of finance, because finance knows no silos. We had a number of faculty that were very interested in looking at sort of that additional value added layer over and above sort of the design that they did within their laboratories and the data that they extracted out of their designs, and then some of the pilot applications that we had out in the field. We said, okay, let's try this. So this is a cross-campus center. It looks at these new business and investment models for smart infrastructure. We're looking at, of course, financial innovation. I'm going to talk a little bit more about that, but also, and most importantly, on the standards and benchmarks, because there is actually not a whole lot of smart infrastructure finance. Most of the finance and infrastructure right now is traditional infrastructure finance. They're public bonds. It's private equity, it's bank debt, and grants. I mean, that pretty much makes up 99% of all the money that goes into infrastructure systems. So we started pitching and we said, you know, we want to invest in smart infrastructure. So who would be willing to fund that? And actually, NSF was not the first place to go, because finance and NSF is something I found out after 3 years, a very tough nut to crack. And maybe you guys can do it through the Research Collaboration Network. But finance, unless finance leads to new economic models, is very difficult to sort of pitch in the context of fundamental science. So I went because I had a lot of connections on the outside. We went to many different types of companies, and the first company that came in was Ripple. Now, Ripple is a blockchain company. Ripple has a cryptocurrency, XRP. Ripple also, for those of you that read the news, currently is in a pickle with the Securities and Exchange Commission, but that is entirely a separate issue. We're not involved in that part. What they were interested in is, well, what they currently focus on is institutional transfer of money across borders. And you say, what the heck does that have to do with infrastructure? Well, not the bulk, but the majority of our infrastructure systems are not just funded by individual states or by the US, but actually have a lot of participation of outside funding. This is funding, whether it's Canada, whether it's Russia, whether it's China, whether it's Australia, whether it's Europe. So there's a lot of cross-border financing going on in infrastructure systems. We were just talking about this earlier when we think about the Paris Accords and all the building of sustainable infrastructure in emerging and developing countries. Most of that money is not in these developing countries. It is in other countries that's on the outside, right? It's any of the member countries, for example, of the UN or of the World Bank. I mean, so they would commit capital to investment capital in these developing countries. So money has to move across borders. And that's a lot of what they're interested in. But they got very interested in this issue of IoT-enabled data streams, right? I mean, if you put load sensors in bridges, or you put monitoring systems and control systems on stormwater management, or you measure humidity and whatnot in soils, I guess, in agricultural land, how can that data be used in the context of a financing model? So how do we integrate that? So they got very interested in that base and gave us $1 million sort of founding gift to start setting things up. Now, the idea, and this is a long play. The long play is, can we completely transform the financing of infrastructure, make it more efficient, make it more, make it cheaper for governments and whatnot to, and create more bankable types of infrastructures. That's the long play, because there's a lot of issues, technical issues, as well as other issues that need to get resolved. And I'm going to come back to this a little bit later. But first, let's take it all the way to the top. We tend to think, and even in the Biden administration now, and previously in the Trump administration, there's always a lot of talk about there is not enough money to invest in all our infrastructure systems and infrastructure models. The problem is not that there is not enough money. There's not enough of the right money. There's not enough public money. There's plenty of money. There's $5.4 trillion worth of money that wants to invest in infrastructure systems, but the business model and the financial model of the infrastructure are not the right one for that model to get, for that money to get invested in. So this is why when we keep talking in the US about the 2 trillion infrastructure finance gap, it is largely the public money, right? And that's, I mean, I show this at about every talk that I give on, on infrastructure finance. Right, this whole motivation, right, that public infrastructure is one thing. I mean, you see all these funding gaps in all these different types of infrastructure systems. This is largely public money, not the private money. Of course, that's why we're going more and more into public-private partnerships to attract non-public money into an infrastructure project, right, for various different reasons. For delivery, better delivery of efficient investment, for and to overcome the fact that we don't have enough tax revenue to actually fund our infrastructure systems. So another thing I should point out is that we tend to sort of nicely put these things into, you know, different silos. One of the exciting parts about data-driven infrastructure finance is that data is not siloed. Data moves across many of these different infrastructure systems. And we talk a lot about connected infrastructures and all these kind of concepts, and particularly in the food, energy, water nexus. Food, energy, water are and represent a lot of connected infrastructure systems that don't easily fit these buckets, each of which have their own kind of money. So we sort of siloed ourselves into a problem, let's put it that way. And the way investors are starting to look at, I mean, through data-driven financing is, can we connect some of these infrastructure types? So this is another important slide, because infrastructure is not infrastructure. And even in the FEW, infrastructure is not infrastructure. From an investment perspective, and particularly when investors come into a public-private partnership, they will look at the infrastructure as an asset class to invest in, right? There is social infrastructure. There's going to be sort of the brownfield regulated infrastructure, and there's going to be demand-driven infrastructure. And these are very different infrastructures. Now, we'll have to think in the context, and I'll do it at the back end of the talk, about which infrastructures are relevant in the context of a food, energy, water nexus. But here's one of the reasons why they're interested in that, right? Social infrastructure like roads and bridges, if they're not toll roads, I mean, is a very low return and very safe investment, right, with 2 to 5% returns. But you want to bring in that additional money, and you want to start thinking about financing and setting up a financing model to shift how we do business in the FEW, or how we do business in the context of carbon finance. We have to think about what is the risk in that system and what are the returns from that system. And again, this is the lens from the outside. When we think about public bonds, it is safe. They all sit over here. Very safe money, guaranteed by the state, often guaranteed by the balance sheet of the state, right? It's very safe. They haven't, I mean, only 6 bonds even failed in 1929, right? In the biggest financial crisis, only 6 municipal bonds failed. So it's very safe money. The problem is there is not enough of a tax base anymore to raise that much of that safe money, which is why we're bringing in other kinds of money. So now we have to kind of think in this kind of context, what type of infrastructure fits under the food and energy water nexus. So let's look at the power of data then. If that is the case, we see that if we want to build, say, renewable energy or smart water systems or green building development, a lot of that is going to be sort of what we call a demand-driven infrastructure, where there's going to be a different willingness to pay for different types of uh, benefits and services that one gets out of a smart system. And so in a system like that, or for technology and for infrastructure like that, the expectations are high return. Now, we have moved a lot more in this direction of demand-driven infrastructure. I mean, a toll road is also demand-driven infrastructure. And as you know, toll roads generate data. Toll roads generate data in the context of who passes through, how many axles do you have, and whatnot. So we're going to look at that much broader than just toll roads. So what's really the power of data, and why are data likely going to influence the food, energy, water nexus? Well, in smart systems that are equipped with more, not just more sensors, but that can be monitored in various different ways, we can peel off layers of the onion of different types of information that is embedded in a system like that. And any system has additional data streams that can be layered on top of it. It's sort of part of that, not quite the digital twinning, but at least digital querying of an infrastructure system. And that's something that we have to do within the FEW also. So smart systems are essentially data streams. Data streams have a benefit in infrastructure finance. Why? Because they unlock what we call informational efficiencies. So data result in the creation of new types of cash flows, new operational efficiencies and savings, and actually even financial benefits from the integration of ESG, environmental, social, and governance benefits. And I'll talk a little bit more about that later on. So as we look at any kind of infrastructure, a building, a road, a smart water system, the information from there now can be peeled into multiple sort of information value stacks. And I'm going to come back to that also a little bit later, what these all are. So impact metrics is ESG. Well, a piece of infrastructure that is rated to have higher ESG and a better ESG rating is viewed to be a lower risk system. And actually the credit rating of that system might be lower as well. If the credit rating of that system is going to be lower, then the cost of actually financing that will be lower also. So there are sort of now that we have a decade plus of sort of looking at environmental, social, and governance benefits around infrastructure systems, we've actually started to uncover sort of new value streams and new financial benefits and new costs, new cost savings that can come out of systems like that. So we have operational savings, we have derivative cash flows where these data are sold elsewhere into other beneficiaries in infrastructure, and then we have the valuation of impact impact metrics. So that's one of the pieces of power data. A second piece of the power data, that's why Ripple was really interested, is like, well, if you know what this is, if you know what these operational savings are, if you know what you need to measure in these systems to actually deliver this information, then we can codify that. And that's where the computer scientists get very excited, right? And they say, okay, we can look at essentially any asset, real estate, renewable energy, electricity, bridges, pipeline, shipping, whatever it is, what you want to do, and actually understand this. We do this through one of our partners, Blockchain Triangle. We look at these different kinds of data streams and essentially put them on what we call essentially a smart contract. A smart contract that says, if performance is X, then payout Y can happen, right? Or if performance metric X is this much, then that much capital needs to be injected into an infrastructure system. Almost in a way, treating infrastructure like, and I hate using this analogy in the context of an academic talk, but almost treating infrastructure as a real asset stock market, which really isn't what it is. But what sensors and what drone monitoring and all these other technologies that have been developed around infrastructure is doing, and whether that is anything from stormwater overflow management by sensors in manholes to inline sensors that we have for soil monitoring and whatnot, that kind of data can be transformed into a benefit. Is it a better crop yield? Is it a lower water runoff, lower nutrient runoff? Is it fewer water overflows? Is it an improvement on energy efficiency use, right? So information like that can be codified and can be put into a smart contract with triggers that allow for payouts. And in fact, the forecast reduction is that in traditional finance, traditional debt from a bank, traditional private equity from investors, you're paying sort of, I mean, the cost of financing. So that this is the cost of actually getting that money. The cost, so not the performance of the money, but the cost of getting the money. Like you go to a bank and you have to pay a fee, to get a loan, right? So that fee, which right now is typically on the order of about 1.5%, that's 150 basis points. We could probably cut that in 3. So by using data information from infrastructure systems that make these systems more performance rich and more data rich, so that we understand how well, when they fail, when they overperform, when they underperform, or when potential other parties are interested in that data, actually can help us in reducing the cost of getting new money for infrastructure projects, which also then helps with how we making more projects bankable, right? The lower the cost, the more bankable projects are. So this is something that and that's what Ripple got very excited about and interested in. So just to give you very specific examples, these are 2 that we're working with 2 of my colleagues. One is Professor Kirkis, probably well known among this team. He works a lot on smart stormwater management systems, right? Where basically it says instead of gray infrastructure, we're going to be investing in smart valving and response infrastructure in watersheds, large watershed systems, and sort of keep water upstream and attenuate the flow slowly downstream so that the gray assets don't get overwhelmed from flooding, for example, right? And so in effect, I mean, this is an example of a project they did, I believe, in Indiana, right, where we start seeing once you actually implement your sensor, or is it the monitoring system implementation, that you get fewer and fewer overflows out of the gray infrastructure system. So basically, active watershed management reduces the need for gray infrastructure spending or financing needs. Right? That's the argument that's made, and this actually is funded by a Leap High from NSF. This is another one also funded, not through Leap High, but through another program. Professor Lynch, who is more on the civil side, he is very interested in how do we finance our roads? There is not enough public money for our roads. Do we have to go to toll roads? No, we don't. We can actually figure out by weigh in motion sensors in roads that can monitor truck traffic and deterioration, consumed life cycle cost by truck traffic, logistics traffic on roads becomes a proxy for a financing decision. You can actually start charging on the registration of trucks their impact on future life cycle cost reduction, right? So that is part of smart financing, where you tap data and you sort of build these back into financial models and into new kinds of revenue models. In the context of, I mean, how that works in a contract is, I mean, again, these 2 systems, the water system, right, and the road system. So here we're looking at an improvement in water overflows, right? Fewer water overflows, or fewer gallons of water overflows. Here we're looking at sort of lifetime deterioration. We can actually monitor that and define different triggers in a contract on, for example, highway deterioration, or even water system deterioration, or stormwater overflow success, right? And what the smart contract would do is, for example, make a call on capital to a state infrastructure fund to say, hey, I need to get repaired. Or you can use this model also to pay private operators in a P3 model that operate a road, for example. In the context of stormwater management, instead of just a fixed fee that you would charge to companies and to citizens for stormwater infrastructure if you live in an urban environment, right? So now you basically have a fee that is very much driven by the success of the system, right? Very different. It's a very different, so it's sort of going from a static system to a dynamic system. So that's really what people talk about when they talk about this smart infrastructure system. And what it does is reducing the cost of getting money for that kind of infrastructure. So essentially what happens now is, if you look at our same risk and return model from before, smart infrastructure, as in infrastructure that has data, right, generates operational efficiencies, can cast off data sets that can be licensed, I mean, sort of much more broadly into other industries, and also confers benefits on the ESG side. And what that does, by having more of a near real-time performance assessment of infrastructure, now we can get away from the expensive money, the private equity, the hedge funds, some of the expensive debt funds, into new kinds of money, i.e. the money that responds to sort of shorter term performance metric, money that can decide when it wants to be in or wants to go out of infrastructure systems. I mean, if you think about it, all our pension funds, I mean, in the US, only 5% of all that money is actually invested in infrastructure. People have been arguing for decades they should invest much more. The problem is that the kind of money that pension funds manage is money that they have to pay out to us, right? Once we retire, there's always claims on that money, right? For pension funds, so it has to be liquid money. And what smart infrastructure financing does, by having sort of near real-time performance assessments, money comes in, money flows out, money flows in, money flows out of infrastructure systems, and can now start bringing in all sorts of other assets of the pension funds into infrastructure. So data give you a lower cost, data bring in new kinds of money, data allow you to tie performance to payment as well as to financing. And so now I'm going to leave this here for a second, because I want to bring it back to from Finland and tie Finland into the food, energy, water nexus. Because infrastructure, when people talk about infrastructure, there's all sorts of definitions, right? There's a definition specifically around a piece of asset, like a road or a bridge or a water system or an energy system. But all these systems are essentially connected to something else, right? So I want to talk about the second piece, which is really the use of data to finance complex systems, such as food, energy, water nexus, and learning from the Finnish experience. So what we've learned from the Finnish project, and what we still continue to implement in our current center, is not only the individual infrastructure systems like these roads and water systems, but it's also think about the system really more as an interconnected network of infrastructures, right? So the pieces, this is kind of the cartoon, right? So we take the real world system, look at the various different data information layers. Now we select data sets that allow us to map financial interdependencies between these key sectors of the economy. So this becomes what we call a financial network map. Financial network mapping is used by banks typically, and it's used by banks to look for fraud or to look for money that transfers across borders that shouldn't be. We are actually mapping that between different sectors of the economy. We're using that to map between different sectors of the economy to then from that define performance characteristics that can quantify the inefficiencies in that system. And I'll give you two specific examples in a second. Once we know what these specific metrics are that can quantify the inefficiencies and that can respond to that interconnectedness, we can now start figuring out, okay, where's the opportunity cost and where are the revenue streams coming from in that particular system. And that's essentially what your business model is. Once you know your business model, you can start thinking about your financing model. So the financing model is really nested within a business model, and the business model really is nested within the system that you actually want to finance. So let's take a very specific example. So this is an example that Jeffrey kind of referred to earlier. So we have, and this just happens to be the Great Lakes region. So the Great Lakes region, all the dredging and all the port management and all the lock management and all that stuff is essentially all done by the federal government, right? It's essentially an appropriation-based funding model, not too dissimilar to how cities, local cities and counties and states often make decisions about what to invest in, right? So there is a pitch made based on a cost-benefit model, right, as to what should be invested in, and then the money is allocated. But he found out, so the student here, Dennis Shagru, found out that is a very inefficient model, because politics plays a lot of role in that, and all sorts of other factors that have nothing to do with finance ultimately decides what actually gets financed. So he said there's got to be a better model, a more efficient model that is more data driven, where the data actually inform maybe a demand-driven model instead of a government sort of allocation model to invest in the infrastructure. So here we're looking at the infrastructure being not a brick and mortar and steel kind of infrastructure. This is the Great Lakes, but the Great Lakes are actually an iron logistics highway, right? So we're not looking at them for water quality or for water quantity. We're looking at them as being essentially a highway. I mean, all the shipping, about 7,000 ships per year, ply back and forth from the top, right, from Lake Superior through the locks to Lake Michigan over here. So they come from here, they go through here, go through here, go through here, and essentially power 11% of GDP of the United States economy. There is a lot of energy that goes into that. There is a lot of course, it is a water issue, and there is a lot of cost associated with that system. There has been sort of, because it is 11% of GDP of the economy, there's a lot of federal allocation. We said, let's look at this very differently, because there's all sorts of users in that system, in that ecosystem. So what is the financial network map of all the industries that actually have a dependency on these Great Lakes systems? And what is the metric we should be using there? We ended up using a metric called inventory turnover. And that is very important, to have sort of metrics that allow you to connect the network. I have, for the last 2 days, scoured through all financial network mapping or all network mapping on the food, energy, water nexus. And there's a lot of those. There's a lot of those network maps, the social network maps. I haven't found one that actually tracks financial interdependencies between food, energy, and water. So here we've been doing this, and we go all the way from the shippers to the steel manufacturers, from the steel manufacturers to the car manufacturers, and to the elevator manufacturers, and all the way on down. So there's multiple stages in that supply chain. And it turns out the bottleneck is really how efficiently these ships can get from here to here, right? From top to bottom. They sort of keep going through that lock, and they depend very much to how everything is dredged and the depth of harbors and everything else. Water levels, all of that. So we're actually developed a metric, a joint efficiency metric that applies to this system that allows us to quantify the opportunity cost in that system. Because once you understand the opportunity cost and the risk in the system, now you can start thinking about a fee structure, right? So we have here all sorts of dots. So every ship carries a transponder, kind of like a GPS system, right? And that is not just in the Great Lakes, it's everywhere globally. But just in the Great Lakes, over 10 years, we took that data, it's about 1 billion lines of code. So 1 billion lines of actual specific data, all these dots, individual data. We actually tracked through data the efficiency of all these ships at any given point in time to get from here to any of the harbors down here, and then tie that into the energy cost, the fuel cost, the time that they're spending in in the harbor, a time it takes to come back. And so we will start thinking about the emissions of these ships, the cost of fuel of these ships, everything else, and the investment that the government makes in these ships. So from that, we were actually able to extract by harbor, very specifically by harbor, what the actual demand, risk, and opportunity cost is. It's not just a generic fee that the federal government sticks in there. There's really a very specific by ship, 7,000 ships per year, 1 billion nodes over 10 years, right? On how efficient these ships are, and we were able to then find out what the fees could be. And now we're setting up, instead of an allocation model that comes from the federal government, something like an infrastructure bank. It's going to be the Great Lakes Infrastructure Bank that lends depending on harbor and shipping lane needs. So that is smart financing. You use data to understand your system, interdependency of the system. You use data to understand the efficiencies in your system, and you use the data to unlock new revenue streams from that system. And that then results, that's how you shift from sort of an entirely inefficient government-funded system into something that is a more efficient. This is still going to be government run. It's a state infrastructure bank, or probably a federal infrastructure bank, but it's based on banking. It's very specific, based on need. All right, so let's look at a second system. I don't know why. Oops, here. That is Finland. Now this gets closer. This is the bioenergy. Remember I was talking about the bioenergy system in Finland? So they were thinking about, they have a lot of forestry, and forestry usually makes timber, right? We're into timber. But they were very interested in this. Can forestry be used, and how do we invest in forestry to actually start developing new commodity chemicals that can be used in all sorts of industries in Finland? They have a very heavy computer industry. They have a phone industry. They got of course, they have a gaming industry. They have a pharmaceutical industry. So they have lots of other industry that takes all sorts of inputs that currently are largely driven by fossil fuels. So we actually mapped out, and this, so I did something wrong here with my mapping system, but anyhow, it's a very complex network, kind of like this. Oh, you see it very briefly there. I don't know why it went away. So I abstracted it from that to say, okay, that system, the financial network map of the forestry system and how it is connected into other industries, kind of in an abstracted way, looks like this, right? As in, there is a link. It's a very faint link between paper products, the paper products component, this part of the industry, and what we call the diversified chemicals component of Finland in the industry. Now, the diversified chemicals in Finland, they typically come from oil and gas, like everywhere else in the world, including in the US. So how does Finland transition to a green chemistry base is by building out this linkage here between the paper products industry there, which already had a link into commodity chemicals, but tie that into diversified chemicals and specialty chemicals to sort of start translating, or replacing fossil fuels in that value chain. Now, what needs to be the performance metric? Well, the performance metric they've been looking at is the replacement cost of fossil fuels with cellulose building blocks. It's a cost over yield of product per unit time, right? Because the industry, the brown industry, right? It's called the brown industry, has a developed supply chain that has existed for 60, 70, 80 years. So we try to transform that by tying in the forestry industry into the chemical industry, right? So we had to sort of deal with a metric that is recognized across this industry and that is an efficiency in that industry. So now we've been looking at building, and what Finland has been doing is investing in these kind of companies and align them with all the chemical companies, with computer companies, with manufacturers, biochemical manufacturers, electronic manufacturers. Sorry, they're here. Electronic medical manufacturers, biochemical manufacturers, electronic, textile. We're in textiles now with big companies, consumer packaging companies, and tying in and figuring out how cost over yield per time can improve on this value chain. The way they were able to do it is because of carbon credits. It's not unlike what we were doing here with mixing in biofuels with fossil fuels, right? In our cars. So if a Bayer or a BASF or a DuPont can take in, say, 20% of bio-based material into that industry, they can start, and get the carbon credit for that. We can improve that cost over yield per time to make this thing happen. In addition to that, they forced green procurement requirements for all government contracts. So between green procurement contracts and carbon credits, they were able to build a financial model that drives private equity, some corporate finance, supported by government venture capital and grants, to actually build out a new industry that will fully engage the paper industry with the chemical industry. And in fact, right now in Finland, the paper industry is not even referring itself anymore as a timber industry. They're a high value added products industry. They're tying into consumer packaging, electronics, textiles, and bioplastics, because that's really sort of the whole shift in that particular industry, using multiple funds. And so our MARFs were part of all of this. Again, smart financing. Understand how your industry links in with the rest of the industries. Understand what the efficiency driver is that you need to address, and figure out how you can actually address that efficiency driver, for example, carbon credits and green procurement. And that way they were able to build a financing model. Just doing one more here. So I have a startup company, and I work with all S&P companies and with all companies on the Nikkei 225 and the US and the Euro 50 stocks index, to figure out water risk management in their supply chains. So the questions that most companies ask, whether you're an agricultural company, an energy company, a manufacturing company, or anything else, is what is my water risk in the value chain, right? How specific is it by facility? Because most corporations have dozens to hundreds of facilities in different localities. And what is the impact of water in this case on my operations, on my credit risk, and on my market share pricing? So again, we're using the same kind of model. We say select a data set that allows us to map financial interdependencies. This is specifically for a company called Asahi. Some of you may know it from Asahi Foods and Asahi Beer. So not an S&P company, where we mapped out, again, that entire supply chain, the financial relationship between these suppliers as a percent of revenue, and the percent of revenue they draw from being a subcontractor to Asahi. So Asahi sits over here. They have sort of a first tier of suppliers and then secondary tiers of suppliers. And when you start looking at these secondary tiers of supply, you find all sorts of companies. Flour mills, not surprising there, right? But you find electronics companies, you find manufacturing and metal mining companies. So this is kind of like a nexus, right? It's a nexus where all types of companies are tied into this company's supply chain. They want to find out, what is our water risk? How much of it is from our own company versus how much of it comes from all these different suppliers? So based on that, what they need to find out, or what we need to find out, is a performance metric that responds to that water risk in the supply chain. And we've been working a lot using water intensity by sales, right? How much water do you use to drive how much revenue? And how much water do you use? How efficiently do your fixed assets, your facilities, use water? And do that sort of at a facility level basis in all the different localities where these companies are. And so we can start mapping out, based on who you are as a company, who all your suppliers are, and what sectors they are. Are they material sector, in the consumer staples sector? I mean, consumer staples is where Asahi is, but they have a lot of materials companies they depend on. Other industrials, these are sort of the manufacturing companies, and other types of companies that all fit in these supply chain, and how efficiently they all use water. And we look at the efficiency of their use of water relative to how much they are tied in financially into the supply chain of Asahi. So Asahi can quantify this is our risk versus this is all our supply risk that becomes our risk. And based on that, now they're making decisions. We can't specify that for them, but the corporate makes decisions on, are we taking on insurance kind of strategies, risk transfer, right? Are we going to be doing water banking? Are we going to be doing supply chain finance, as in sort of force condition our payments to our suppliers based on their reduction of their water use, right? Or are we actually going to be investing in equipment, physical equipment in our different facilities? But they wouldn't know that unless they actually had insight on all of this. Actually, just this morning out of Japan, I got specifically this question. I said, we have absolutely no idea as a company what the impact is of water on our operations, on our credit risk, and on our market share pricing. And those are the things that we are looking at. So 20% operations risk, 170 basis points in share price, so 1.7% difference in performance based on high versus low water risk, and 75% of the risk comes out of their supply chain, right? So they have to sort of get that characterized through data to understand how they look at their supply chain. Now, the last couple of slides, in the interest of, and I know we're butting against time, but I was looking at this nexus, and the nexus looks exactly like any of the industries that I've looked at, right? Energy and water and the food distribution and whatnot, but we have no idea what the financial interdependencies are. We know something about macroeconomic data, as in climate change impact on water, embedded water risk. It's actually quantified by ING to be 145 trillion assets under management impacted by water, all these other, but it is not actionable. We don't know how to finance this. It is also very dependent on what the perception is. The UK may have a different perception from California, different perception from New York on what drives the food, energy, water nexus in their localities. And that is something from an infrastructure investment that we need to understand. Does it have inbound arrows or outbound arrows? Meaning, if it's inbound, it is really not an influencer in the food, energy, water nexus. If it has outbound arrows into other, sectors of the economy, then it does have an impact on the economy. So understanding what the localized perception is of people in this industry or of public asset managers is very important to actually make a decision on the financing model. Again, very heavily data driven. And I think in the interest of time, I want to just leave this up. Actually, I don't want to leave this up. Sustainability is a very big part of what we do. We have now a big project with the Great Lakes Protection Fund that involves ING, BNP Paribas, a couple of banks, Morgan Stanley, to sort of figure out how we condition money going into infrastructure based on sustainable outcomes. And I sort of want to leave it at that. And apologize, this was a lot of information at specific facility level and at industry sector level. But you think about the nexus, and it's a very complicated system. Thank you.
Thank you.
Thank you, Peter. This is very enlightening. I think there are quite some questions in the list. Nuri, would you like to call for the questions?
Yes, hi. Thank you, Peter, very much for your presentation. I don't know if Michael still has time to ask. He had one question, but he was about to leave. Michael?
I can try quickly to ask my question, and I apologize to everyone for reading it. It's in the chat. But Peter, thank you for a really stimulating presentation, very challenging. Mm-hmm. I have, maybe it's a simple-minded question, but it seems to me that the message implies a shift towards performance-based private markets as a main element. In that, there's a parallel in electric industry deregulation, where one of the outcomes was efficiency in capital allocation, mm-hmm. which caused investment to try to just equal market demand. Mm-hmm. The result of investment just equaling market demand was that the industry's reserve margins plummeted, and those reserve margins are what buffeted pricing in the market. So electric prices went up for everybody.
Mm-hmm, mm-hmm.
So my question is, do we essentially all need to expect to pay more one way or another for infrastructure services, whether it's through private or public funding or whatever mix?
Not necessarily, no, because you know, is a great example that we're working on right now. I don't know about water, but sort of again in mobility, right? So the state of Michigan wants to build, the DOT, Department of Transportation, wants to build autonomous vehicle corridor. They say it's $100 million. There's probably very little actually going to come from the state. So, but typically what states tend to do when they set up these P3s or the RFPs for P3s, it has conditions in it, right? And so the conditions very often are social, environmental, and increasingly equity kind of conditions related to how the infrastructure will be built, operated, financed, and how revenue will be drawn. Like, for example, we see that now states will say, look, we want the private sector to build X, but this road, but you can't make it a toll road because it has to be socially equitable. And so I think what we're going to start seeing is that data, right? These data are not just data that we pay as users. A lot of the data streams and the data revenue off of infrastructure systems comes from business to business transactions. And I agree in your case with the energy system. Ultimately, it boils down to what your energy rate is, right? And that ultimately then, kept going up and up and up. In this case, it is not like that because we're creating all these derivative income streams or revenue streams out of smart infrastructure systems that have nothing to do with you or me as a user. But that are, as I said, it's a digital business economy. I mean, start thinking about Uber. Uber makes 3 times more money from the selling and reselling and licensing of data than it makes from the actual right that you pay for.
Right. Okay. Thank you. It's an interesting answer. The use of derivatives always makes me a little nervous as the source, but I hear what you're saying, and I thank you for that.
You're welcome.
Thank you very much for the presentation.
Yeah.
We have one more question from Jorge Aponte Gomez.
Jorge. Sorry, you're mute. Still can't hear you.
Okay.
Yeah, now we're good.
I was working with Cerrejón. This is a mine called located in La Guajira, in the north region of Latin America. Okay. We were working with the Wayu community. It's indigenous people located in La Guajira. And I was working with a shovel system that described the way we mine the coal for the operations. But we need to know, even we have all the logistics and the SCADA systems, we need to face the interaction with the community. How to deal with the soft things that a model cannot incorporate.
Right. Right. No, that's a very, very good point. And that's one of the reasons why I put that slide in earlier. This whole perception map, right? And that is basically, I mean, at one point you do have to bring in the community, I mean, before you finance anything in particular, right? So there's going to be the public asset managers, it's going to be community leaders, it's going to be others. I mean, like the same with this road, it brings in the mayors, it brings in township managers, it brings in all sorts of people to start looking at, okay, well, what are the conditions? What are the perceptions of risk and needs in our community, and where is sort of the both the political, the cultural, the other willingness to pay in that system? It becomes a condition on how you finance the system. But first, understanding through here, this is not a financial network map, by the way. This is sort of it's a social perception network map. on how first participants, I guess, that look at food, energy, water nexus see what is actually driving and what is sort of on the receiving end, I guess, in food, energy, water nexus. So getting the input from the population, I mean, absolutely is going to be key in the financing model. I mean, Florida has no problem with toll roads. Michigan, no toll roads, right? So, I mean, so there is already a cultural difference, historical difference that's very different. Some systems, some environments don't want any private capital. I mean, I'm not advocating that everybody should get private equity and everybody should do blockchain financing, but not, absolutely not. There's going to be that efficiency metric, right, that you're going to be looking at, but there is sort of that perception of the soft, I mean, the social and cultural perception that's going to influence how you're actually going to finance that whole model once you've identified where the inefficiencies are. So, and that's, I mean, we're right now, I mean, we have, for example, just on this one, this again, it's a road, it's not water. There are 5 working groups. There's land management working groups. There's technology working groups. There's social equity working group. There's the business and financing model working group. And there's a policy working group. And all these working groups ultimately will result in what the revenue model or the business model is going to be, and what the financing model is going to be. You know, so you have, that's sort of all kind of a precondition to everything else. But understanding what connects what and where revenue could come from is a very important characteristic in the infrastructure system. I hope that helps. Thank you.
Thank you. We have one more question, and I think it's for the closing. Thank you, Professor Ajami.
Absolutely.
Peter, thank you so much. That was great. I have a question, and maybe sort of like a comment here as well, which I think what you are presenting here is always fascinates me, because it provides an opportunity for a lot of different participants in the process rather than one single industry trying to do it all by itself. Mm-hmm. And I think this I'm not sure it's the right word, but it sort of democratizes the process, because right now we make all these investments in one industry without necessarily thinking about the consequences or interconnections to the other industries. Right. And we don't take their money. We don't think about them as much either. We just make sure that we meet their permit requirements or whatever boundaries that the industry has set on us. So think about, or sector, think about water and transportation, for example. You know, all these roads have to deal with stormwater, but they just try to do the minimum amount of work they need to do to meet all the requirements. But something like this can provide an opportunity for sort of aggregation of resources, and also maybe a little bit more thoughtful process of how these systems sort of interact and can work together. So potentially, even if you don't think about them as a necessarily as a private money aggregation, it can actually create a more efficient public money aggregation that we don't have right now. Right.
Actually, I want to just very quickly go back to that slide that I showed from that included Jerry and where was it? Jerry and Branko's work, right? There is nothing that says in data-driven financing that you have to keep, you know, your construction of roads and bridges separate from stormwater management, right? I mean, we have created that model, right? I mean, that you and I agree on that. We've been talking about that forever. But this could be one single project where some of the feeds the data from here and the data from here actually, as you said, consolidate and bring efficiencies in how a public sector actually finances infrastructure. You're absolutely right. So I mean, I'm just agreeing basically here, but it allows for consolidation. Yeah.
I really appreciate it, Peter. It's, you know, you and I have known each other for a while, and I have seen you give a lot of different talks, but this was really fascinating. I learned so much. I have to go back and talk to you about a number of those case studies that you presented here.
High level.
Yes. No, I mean, I think they were perfect. I really appreciated that. It was a great set of examples that we can absolutely take from. I don't know if there is any other comments or questions. Otherwise, I want to thank you for taking the time and joining us, and for your great presentation, and for everybody who participated and asked questions and interacted with the group.
Thanks very much, Nusha. Thanks, Cecilia, for this opportunity. Sorry for running a little bit late, not giving enough time for Q&A. But please do send, I mean, my email, I think, is given out.
Sure.
Shoot me an email, and if you want to have any follow-on questions via email as well. And otherwise, I'll try to respond to the ones in the chat.
Sure. I'm glad you're looking at the chat, because there were a lot of comments on how great it was, and thank yous, and a lot of thank yous. So we are grateful. Thank you, Peter.
Okay. Thank you so much.
Thank you very much, Peter.
Bye-bye.
Have a great weekend, everybody.
Yeah, have a great weekend. Thanks.
Yes, have a great weekend. Bye-bye.